A particle P sets off from the origin at t is equal to 0 and starts to move along the x-axis in a direction of increasing x. After t seconds, P has a velocity of v meters per second, where v is given by vt is 12t minus 2t squared, t being between 0 and 4, and 32 minus 4t when t is greater than 5. Find the displacement of P from the origin at t is equal to 4, and find the time taken for P to return to the origin. Okay, so we know that S of t is the integral between 0 and 4 of Vt. So to find the displacement after 4 seconds, we will need to integrate the first part. This is called a piecewise function, so we need to integrate 12t minus 2t squared, dt, from 0 to 4. So integrating, so it's 6t squared minus 2/3 t cubed. Then we put the limits at the end at 0 and 4. And then substituting in, so it'd be 6 times 4 squared minus 2/3 times 4 cubed minus 0. Just check carefully that it does actually give you 0. And then using your calculator and the fraction button, that will give you 160 over 3 meters, or 53 1/3 meter. Now for part B, you need to find the time taken for P to return to the origin. So after 4 seconds, it's 53 1/3 meter away. So we'll need to consider the second case where t is greater than 5. So consider where t is greater than 5. Vt is 32 minus 4t. St will just be the integral of that 32 minus 4t dt. Integrating it, 32t minus 2t squared plus a constant. Now we can find the constant because we know from part A when t is 4, s is 163. That's the point where it changes from being one function to the other. We can't use 0. So we're going to have 160 over 3 minus 32 times 4 minus 2 times 4 squared plus c, which gives c as 160 over 3 minus 32 times 4, which is 128, minus 2 times 4 squared, which is, plus, because you're taking this over here, so it would be plus, this one will be minus, and then using the fraction button of the calculator gives minus 128 over 3. For the particle to return to the origin, s is equal to 0, so we'll need to solve this with our value of c. And I'm just writing it in the way of a quadratic, minus 2t squared plus 32t minus 128 over 3 is equal to 0. So we could either use the quadratic formula, or we could use our graphics calculator. So using the graphics calculator, we need to go to equation, so we'll need to move the cursor into that and enter that. And then we want f2 polynomial, and it is a degree 2 quadratic, and then we'll need to put values in. So we will need to do minus 2, enter, 32, and minus fraction. Sorry, we need to, the fraction button doesn't quite work like that on this one. So it's 128 fraction 3, enter, and then F1 to solve, and we get two values. We get 14.53 and 1.46. The calculator does give exact mode, so if you want, just press S to D if you want the fraction one. Okay. Now this one here is not possible because the equation is only valid for t is greater than 5. Okay, so returning to our problem, we're going to have, using GDC, we're going to have that t is at 1.468 seconds. Note, not possible, you should actually write that as t is greater than 5, or that t is equal to 14.531, which is equal to 14.5 seconds. Okay, so let's now have a look at this whole problem using some graphs using Geogebra, and the link to the Geogebra app I will put in the notes of this video. So let's just get rid of the calculator. So just closing down the calculator. Okay, and now we've got this app here. Okay, so here we've got the velocity function. Okay, and we can see it's moving like that, and this point here is where it changes direction, so it moves away from the origin, and this is the maximum point it actually gets at 85 1/3 when t is equal to 8. This is where it will change direction, okay, because it crosses from one side of the axis. The velocity function crosses from one side of the axis to the other, and then it goes back at 14.53. It will get back to the origin. At t is equal to 4 is where the first function finishes and the next function begins. You can see this one is actually a straight line. Now, if we click at the bottom here, we will get the displacement function. This is the displacement function. So you can see it gets up to this point. You can see here, this is the furthest it gets away from the origin, and then it comes back to the origin at this particular point here. After that, it will start to go backwards. It will start to go down to this area here, move along in the negative direction. Let's just raise this a little bit so we can probably see. There we go. We can actually see here the displacement function as a piecewise function as well. Like I said, the Geogebra app I will put in the notes of the video. I hope you've understood, and I thank you very much for watching.